Hi, I'm Bill Purdy. I'm going to share my thoughts on reliability for NewSpace. But first, I'll open with a little philosophy. About 10 years ago, I was supporting a large program that was insisting on a reliability of the satellites to be 90%. However, they'd accepted a 3-year launch delay. And this bothered me. And I said to myself and to some of my friends, I said, you know what? If you insist on a 90% reliability, but you accept a 3-year launch delay, the only thing we know for sure is that we've achieved 0.0 reliability for the first 3 years of our mission. Clearly, I look at things a little bit different way than a lot of people. Now, traditional space programs have achieved very high reliability, but at tremendous cost. And the tremendous cost means it's not acceptable for NewSpace. So in reliability for NewSpace, first of all, we have to ask ourselves, what about reliability are we trying to achieve? Is it the reliability of the satellite? That's important, but that's not the whole story. How about reliability of the constellation? That's super important. However, consider this. We build the world's most awesome constellation with great reliability, and we go broke in the process. What have we accomplished? Nothing. In NewSpace, the reliability we really must achieve is the reliability of the business plan, the reliability of our enterprise. So, with this in mind, let's begin our detailed examination of the various tools and techniques we can use for reliability and how they really help or hinder the reliability of what we really care about, our business plan. So, let's go to the whiteboard and let's discuss how to achieve the reliability that we want to achieve for NewSpace, which is the reliability of our enterprise. First of all, to be reliable, there are several aspects of reliability we must achieve. We must meet our performance requirements. We must survive our environments, the space environment, the launch environment. We must avoid parts failures. We must manufacture our systems correctly. We must stay within cost requirements. We must launch on time. You know how I feel about that. Our mission ops, once we've launched on time, they need to be successful. Our software needs to be good, and our launches need to be reliable. Now we've got a variety of techniques, and we will look at each one of these techniques and talk about how they improve reliability and how they may act to degrade reliability as well. Good design, test, design margins, and design flexibility. Design flexibility means the ability to work around problems. Redundancy, mass production. Now in the world of NewSpace, we can take advantage of mass production. In traditional space, very few things were actually mass produced. Nuts and bolts, electronics piece parts, that was about all that was mass produced. All the rest was pretty much custom built in small batches. Analysis, the various analyses we can do, stress analysis, circuit analysis, worst case part stress analysis, and reliability analysis. Quality assurance and mission assurance, and training for operations. So, good design, in fact, great design. We love to have a great design. A great design is very important for meeting mission performance and meeting our environments. The time it takes to produce a great design delays our schedule and costs more. So a great design has a price there. Now, interestingly, a great design, while it costs us more in time to produce, in the long run, it can be the biggest cost savings we've got. If we've designed a great, simple, easy to manufacture system that meets all our requirements, that can save us tons of cost when we go to build the system, and it can save us lots and lots of time. Good design will also help reduce parts failure, because if you have more simplicity in your design, less parts, you have less parts to fail. Software, we need great software. That means we need great software design. Good design will actually make mission ops easier to achieve successfully, simply because a simple design will be easier to operate. Test. We're engineers, we love test, and test is very important to proving reliability. Certainly in the mission performance and in the environments. Test will help us avoid parts failures, because if we're testing our parts, we will find problems before we integrate them to the satellite. It is a good tool for making sure that we've manufactured things correctly. Test, however, is expensive and it is time consuming. So we will have to make tough choices on how much we can test within the constraints of cost and schedule. Sadly, we will not get to do all the tests we want. We will have to pick our best tests and come up with very well-designed test programs if we're going to stay within cost and schedule. Test like you fly will really help your mission operations go smoothly. If you're testing your satellite using a large subset of your mission operations ground software, this will prove out these interfaces. Testing is always very important for software. I think we all know that. So when you look at test, you've got some big pluses, but you can't test forever. You just don't have the time and money. Design margins. So I'll give you some numbers to explain what I mean by design margins. Let's say I've got a 2-to-1 design margin. If the system operates at 100% of its normal capacity, but it only needs to operate at 50% to succeed, we'll call that a 2-to-1 design margin. We'll use that for this example. So, design margins will certainly help you meet performance, help you survive environments, in that if your performance is off a little bit, you're only getting 90% instead of 100%, you're still going to work because you needed 50. And similarly, if the environments are degrading your part, especially when you think about radiation degrading electronics parts, you have more margin against a circuit failure as your part performance degrades. And so that will help you with parts failures. Margins will be expensive. Typically, as you build larger design margins, you will tend to be heavier. You may be more expensive to build. That weight will cost money to launch. However, these design margins may help you with schedule. If we've got our 2-to-1 margin, we can set our pass-fail criteria at 90% rather than 99% if we had low margins. And that will allow us to accept a wider range of variability and still have acceptable parts where we don't have to delay and start lengthy failure investigations for a minor degradation in performance. Redundancy. So, first of all, redundancy, not everything is redundant. There are two fundamental things that are not redundant. The software. There's no such thing as software redundancy. The design. There's no design redundancy. If you have two identical parts and they both are designed wrong, you have identical failure modes and they'll both fail. Redundancy, however, presuming everything's designed right, will do great things to avoid parts failures, because if you have a random parts failure in one unit, you switch over to the redundant unit and you keep on going. It will help you with the environment. If the environment, some of the random nature of the environment tends to, say, zap one part with radiation, you can go to the backup unit. Redundancy is a huge cost impact and a significant schedule impact. Redundancy, basically you're building two of the same thing, so you're pretty much doubling your production costs. You're also lengthening your schedule, and because you've got a redundant satellite, all your redundant things means you're roughly twice as heavy, and that costs more money to launch. So there is a very big price to pay for redundancy, although it does help you, particularly in parts failures. Now, a subtle aspect of redundancy and flexibility is in these constellations, how many spare satellites do you build? If you need 10 satellites and you have 12 on orbit, you have a lot of flexibility for 1 or 2 failures, but not a lot. And you might have graceful degradation in that you want 10 satellites for full performance, but with 9 you're still pretty good and you still got a usable product out on the market. So there is value there, but that too has a cost. Each satellite costs a certain amount to build and launch. Mass production. So we haven't been able to take much advantage of mass production until recently in our satellite components. Now companies are starting to produce full components, reaction wheels and whatever, mass produced, and this has great opportunity for us. Now, the one downside to mass production is that if you have not set up your production line, you will have some cost and schedule to do that. However, once you have the mass production, or if it's already existing, you get tremendous savings in cost and schedule. Things are just being built much cheaper and much quicker. You also get some nice reliability out of mass production, because once you've entered mass production, you've really got your manufacturing processes down and you're building the parts very consistently, very reliably. So there's big benefits there. And so mass production can be a huge benefit, especially once we've crossed the bridge into achieving good, reliable mass production. Various analyses we can do. Think worst case analysis, stress analysis. Certainly helps us meet performance environments. The electrical parts stress analysis will help us have parts failures. This is where reliability also comes in. You can use a reliability analysis. It's not for predicting the fielded reliability, but it's a great comparison tool to compare two circuits against one another. The reliability analysis of one circuit to another is a fair comparison and can tell you which circuit is going to be more reliable. So there's benefit there. Analyses take time and money. They act to slow down the design process and add to the cost. So, as with everything, there's a balance. Quality assurance and mission assurance. Now, in the world of traditional space, there are very well-developed, very, very thorough mission assurance and quality assurance processes, and they have a track record of producing very reliable satellites. However, they are very extensive, which means they add a lot of time to your production cost, your production schedule, and they add a lot of cost. However, you can't just say, well, you know what, that's expensive, we're not going to do anything, we're just going to bolt it together and make sure, run a couple tests and hope it works. That won't be a good answer either. We're going to have to look for balance. So, we certainly have the cost and schedule impacts of mission assurance. Mission assurance, very good for avoiding parts failures. That's what it's really best at. It's also best at making sure we've manufactured it properly. All the inspections we do. It's largely about making sure things were manufactured as they should be. So a couple big pluses, a couple big minuses. Operations training. Many satellite programs put off operations training until the last minute because they're so focused on getting the satellite built. And this can have a net negative impact to reliability because you're not ready to fly the satellite well. So operations training is a big benefit naturally for mission operations and for the software also. Again, this is part of the fly like you test. The flight software on board the satellite has to be extremely compatible with the ground software, and the more you're testing that, the more you're driving it in mission dress rehearsals, the more reliable that integrated software system is. You've got software on the satellite, software on the ground. The software doesn't know if it's on the satellite or the ground. It's all ultimately one interconnected system that needs to work together. There is a cost to mission operations training, and you just have to start your mission operations team earlier and invest in that training. So, as we look through the board, we realize the one thing I didn't talk about or put any buttons on was launch, because it's not as direct as that. Now, we need reliable launch. If the rocket blows up, our satellite blows up with it, and that is a reliability of 0. Now, if we put all of our satellites on one rocket, and that rocket blows up, we've now just blown up our entire enterprise, so that's not good. So, launching on multiple rockets certainly acts to improve the reliability. Being compatible with different brands of rockets, different types of rockets helps reliability, and it helps schedule. A big part of launch reliability is going to be launch schedule. If your launches get delayed and delayed and delayed, that's a big impact to your business plan. If you are compatible with multiple launches, multiple rockets, you can switch from one rocket to another in the case of schedule delays. However, to be compatible with multiple rockets, that makes the design a little bit more challenging, and you've got multiple different environments you've got to survive. So there are a lot of aspects to launch that really drive reliability. We don't have a crystal ball. We can't foresee the future of what's going to work and what's going to not. and who's going to have schedule delays and who isn't, but it's a big part of our planning and our planning for reliability. So, with that, I've taken a good look at the various practices we have to improve reliability and the impacts. And I hope I've given you a good understanding. I've given you a lot to think about. I'm sure you realize there are no easy answers. For every good thing we do, there's a bad side of it, usually cost and schedule. Test is the best example to me. As engineers, we love to test. More tests are more reliability, but at the enterprise level, cost and schedule must be respected. So I think the choices we must make in achieving reliability for NewSpace, fascinating challenge, a very significant challenge, and one of the big things we must be able to achieve to be successful in NewSpace is to drive lots and lots of cost out of the system, yet still have a reliable system. This is a great challenge. I think we're up to it. I enjoy participating in it. I look forward to participating in it more. And I look forward to seeing you all out there in the world of NewSpace. Thank you for watching my video. I hope you've enjoyed it, and I hope you've learned something. Thanks. See you next time.